Okay, so for this lesson, we're going to learn how to solve systems using the substitution method. We've done the graphing method already, and this one's a substitution method, and we've got one more to do tomorrow. But when we solve using the substitution, you need to solve one of the equations for one of the variables, either x or y. When you're solving for one of the variables, x or y, you want to solve for a variable that has a coefficient of either 1 or -1, because you want to avoid all fractions. So if you can avoid fractions by solving for either x equals or either y equals, then that's what you want to do. Step 2 says once you solve one of the variables, one of the equations for one of the variables, you're going to substitute that expression that you just did into the other equation and solve for the other variable. Sounds confusing, but it won't be in a moment. So once you've solved for one of the variables, you take that value and you're going to now substitute that value into either original equation and solve for the missing variable. Your solution is always written as an ordered pair. Don't forget parentheses x comma y, and then you can always check your solution into both equations. The check should always be true for both equations as well. So here's what's going to happen here. So we've got these two equations. The top one is 4x minus 2y equals 14, and then the bottom one is y equals -2x minus 3. Well, that's great. We've got a y equals equation already. We're going to take what y equals from the second equation, and we're going to substitute it in to what the y is equal to for the first equation. So what ends up happening is you get something that looks like this. Your first equation is 4x minus 2y equals 14. And what the y is equal to in the second equation is -2x minus 3. So that's the substitution part. Now you have to distribute up top. So I've got this 4x comes down. When I distribute into the parentheses, I get another 4x. Distribute again, plus 6 equals 14. So then what you're going to do here is combine your like terms. I'm trying to make this thing raise up. Come on, there we go. So then what you're going to do now is you're going to combine like terms, and you're going to say 8x plus 6 equals 14. Subtract 6 from both sides, get 8x equals 8. Divide by 8 and get x equals 1. Now you're going to substitute again. You're going to pick either the top equation or the bottom equation. I'm going to go for the bottom. The bottom equation is this. My bottom equation is y equals -2x minus 3. Well, I just found that x was 1. So that's what I'm going to plug in here. When I do the math, I get y equals -2 times 1, -2, minus 3, or y equals -5. So my solution says when x is 1, y is -5. And when I put that solution into both equations, I get true statements. For example, the first equation, 4x minus 2y, well, 4 times 1 is 4. -2 times -5 is positive 10, and 4 plus 10 is 14. And the bottom equation, -2 times 1 is -2. -2 minus 3 is -5. Okay. Next one, neither equation is solved for a variable. So if we wanted to, we could solve the first equation for x, or we could solve the second equation for y. This is not oriented. So you need to pick what you want to do. I'm going to go for the first equation. I'm going to say, well, if I solve this first equation for x, and I subtract 2y on both sides, x equals 2 minus 2y. Now I'm going to take what x is equal to, and I'm going to substitute it into the other equation for x. So what happens is 3x plus y equals 16. Well, we know that the x is the same as 2 minus 2y. Distribute 6 minus 6y plus y equals 16. Combine like terms. 6 minus 5y equals 16. Subtract by 6, 5y equals 10. -5y, excuse me. Divide by -5, and y equals -2. Now I have to choose one of those two original equations. I'm going to choose 3x plus y equals 16. So 3x plus y equals 16. 3x plus negative 2, or really 3x minus 2, if you will, equals 16. Add 2 to both sides, get 3x is 18, divide both sides by 3 and x is 6. So my solution for the second problem is when x is 6, y is negative 2. Okay, next one. You already have a y equals equation. You've got an equation solved for a variable. You'll take what y equals, I'm so not oriented, and you'll dump it in for y. So it's going to look like 3x minus y equals 7. Well, 3x minus 3x minus 7. You need to distribute. You need to understand that what you're distributing in is a negative 1. So you end up with 3x minus 3x plus 7 equals 7. When you combine like terms, the x's cancel, and you get this true statement. 7 is in fact equal to 7. Well, it turns out that when you have a true statement, the lines happen to be coinciding lines. For example, if I were to actually take the second equation and solve it for y, I could add y to both sides. I could subtract 7 from both sides. And what you should notice is that these are the same exact equations. So these are lines that coincide. They're the same line, basically. And we learned from graphing that if lines coincide, it's not just that there's one point of intersection, there's not just one solution, but there's all points of intersection or infinite solutions. So the solution then is infinite. They're all solutions. Okay, one more example here. So now you've got to solve one of the equations for one of the variables. Why not solve this top equation? Let's go for y equals here. So then becomes y equals negative x plus 16, because you got to subtract x on both sides. You take what y is, you dump it in for y, and you get 2y equals negative 2x plus 2. We know we're dumping in negative x plus 16. When you distribute, you get negative 2x plus 32 equals negative 2x plus 2. If you try to add 2x to both sides, the x's completely eliminate. They turn into a 0. So what you're left with now is 32 equal to 7. I'm sorry, 32 equal to 2. Well, that is not true. 32, let me fix this up a little bit. 32 is not equal to 2. So you don't have a true statement. What's left over is false. What this means is there are no solutions. And the reason why that is because if we were to put both of these things into y equal, we would get slopes that were the same with y-intercepts different. So these lines happen to be parallel. So just like graphing, you could have one point of intersection, no points of intersection, or all points of intersection. Okay, so there's some word problems associated with this as well. So if you want to set up a system involving word problems, you need to write a let statement in order to define each variable x and y, set up a system of equations using those two variables, solve it by substitution, and check your solution. So here's our situation. During a football game, the parents of the football players sell pretzels and popcorn to raise money for new uniforms. They charge $2.50 for a bag of popcorn and $2 for a pretzel. The parents collect $336 in sales during the game. They sell twice as many bags of popcorn as pretzels. How many bags of popcorn do they sell? How many pretzels do they sell? We're dealing with popcorn and pretzels. So let x equal the popcorn. Let y equal the pretzels. Well, we know that the popcorn is $2.50 a bag. So $2.50 x is for popcorn plus The $2 Y, the $2 a pretzel, gave them $336. We also know that they sold twice as many bags of popcorn as pretzels. So if that's the case, we know that popcorn is going to be twice the number of pretzels. So X equals 2Y. Then what we need to do is solve this by substitution. Well, we know that X is the same as 2Y, so we're going to substitute in 2Y for wherever we see X. So it's 250. X plus 2Y equals 336. We're going to substitute in 2Y for the X. And then when we do the math, I'm trying to make this thing go up again. There we go. So then when we multiply through, we're going to get 250 times 2Y is 5Y plus 2Y equals 336. 7Y equals 336. You might want a calculator. Divide both sides by 7 and Y equals 48. So therefore we know that there were 48 pretzels that were sold. So pretzels were 48 of them. All we need to do now is figure out how many things of popcorn there were. And we know that popcorn was twice the amount of pretzels. So if we basically just substitute in 48 for the Y and double it, we would know that popcorn is going to be 96. So 96 bags of popcorn. So here our answer is not being written as an ordered pair, it's being written as an actual word problem. 48 are pretzels, 96 are popcorn, so you label your answers. All right, let's try one more. Laura has $4.50 in dimes and quarters. She has 3 more dimes and quarters. How many quarters does she have? Well, let's call X the dimes. Let's call Y the quarters. We know that she's got 3 more dimes than she does quarters. So that means dimes is going to be 3 plus Y. So dimes equals 3 plus quarters, okay? Because she's got more dimes than she does have quarters. And we know that the total value of the money is going to be $4.50. Well, dimes are 10 cents per dime. Quarters are 0.25 cents per quarter. The total amount of money she has is $4.50. We've got an equation solved for X equals. We're going to plug X equals into the X, and we're going to see that 0.10 cents X plus 0.25 Y equals $4.50. Remember what's going in here is 3 plus Y. When you distribute through, you get 0.30 plus 0.10 Y plus 0.25 Y equals 4.50. Let's see if I can bring this up. When I combine my like terms, I get 0.30 plus 0.35 Y equals 4.50. Subtract the 30 cents from both sides. 0.35 Y equals $4.20. Divide both sides by 35 and you get Y equals 12. It's asking you for how many quarters you have. Well, that's what the Y value is. So while we can answer the question for dimes and quarters, it just wanted quarters. It just wanted Y value, and so we know for sure that we have 12 quarters. Okay, and that's it. Good luck on the homework.